Okay, perfect. Hello, everyone. Good afternoon. Thanks, all of you, to join me for this talk, where for the next 25 minutes, I am going to show you what has been done in openSUSE distributions to secure the boot chain using the Unified Kernel Image. So my name is Valentin. As you can guess from my accent, I come from France. I have joined the company 3 years ago now to join the team that work in boot and initializations. I maintain some packagings into our internal distributions like Linux PAM, Auto Tools. And some years ago, I have been investigating to work on study the Unified Kernel Image. So where I come from these presentations today. Some important points before these presentations on whole work around that has been made for systems that work on the UEFI firmware, only tested on x86-64 architectures. So firstly, I need to bring you back to the boot chain, where we find some things. When you power up your machines, you will have your UEFI firmware that will run to initialize your hardware. Then shim, the Microsoft Sign bootloader, will then run, and run sign other bootloaders like grub2 or systemd boot, depending on your systems. To after run kernel into an initial ramfs, where the initramfs, or called Initrd, it's an archive, CPU archive, that has been pre-generated into your system that will include all initialization service for initiate your system. And to be as minimal as possible, it's building into your systems. Therefore, into these boot chains, everything is secure except the initramfs, because initramfs will not be signed by the vendor for the good reason that it has been built locally. So yes, your boot chain could be corrupted, and for that, we are thinking about maybe we could provide an image that will include a static and signed Initrd. So we want to know if it would be possible to build this kind of Initrd into our open build service to provide it into packaging. So here is a plan to secure the image. First, I will show you how we can build or publish the static Initrd. Then, after seeing some limitations, we will go to the Unified Kernel Image sections, where I will show what it is, how it can be built and published, and some work actually in progress, some experimental works. Perfect. So the first questions, how can we use to build the static Initrd? In fact, we have two options nowadays. We have Dracut and mkoz. And I think you already knew the Dracut. Dracut is a tool that we already use to build our static Initrd, I mean the Initrd in our image. It's using shell script, and it's built initramfs with what is available on your machines. And it works as a module. You will tell Dracut to build your Initrd by a list of modules that will include chosen files. On the other hand, you will have mkoz. mkoz is a tool developed by systemd using Python, and where Dracut work on the module. mkoz will work on the package. So it becomes more deterministic when you build your Initrd. But therefore, you could eventually include some additional files that you don't want into your Initrd. And also, it needs some internet connections by default to work with mkoz. I will not compare the both tools, because they will have a great presentation Saturday by Antonio that will focus on the comparison of both tools. But for my case, to build a static Initrd, I would keep using Dracut because it's the tool that we already used, and it's more adapted to use in OBS. But keep in mind that there is some proofs of concept that already used, and mkoz can be used also to create static Initrd. So just to have an idea of size, that has been generated from the past, but it's the size of what a generic Initrd could be, following these both tools. Okay, so now we have chosen the tool, how I have published them. I mean, how I publish a static Initrd. So I have created packaging using a spec file called the static Initrd. It will follow the kernel versions with what it has been built, and it is into the build sections where I am calling the Dracut commands. I build it in a reproducible way, and the most important things, I am using the no host only arguments that allows me to tell Dracut to build an Initrd, not of what is available, but it will try to build the most generic one. And also we have the idea to not only provide a generic Initrd, but maybe provide dedicated Initrd, maybe something that will include more or less some modules. So I have providing a configuration files when you have the possibility to add other modules into lists. So actually on factory, so therefore it's available on Tumbleweed, you can already install this kind of static Initrd. So we have some packages called static Initrd. It's followed by the dedicated name. So I have building 3 of them. The basic one, the base one, it will include really minimal list of modules, and it should work for most of the case. Generic ones, it's the ones that include all generic modules. And network ones, it's as an example of dedicated Initrd that we can have, actually. Then it follows with the kernel flavors with what it has been built. So for now, it builds again kernel default and kernel vanilla. And it's affixed by the unsigned. And it provides an unsigned static Initrd. And now I think you want to say that there is an issue where we provide unsigned Initrd, and I show you again an unsigned Initrd. Is it because just with that we have some limitations? Nowadays, it's not possible to directly sign the static Initrd as it's still an archive. And moreover, today's our bootloaders will not attempt to verify the Initrd. They are used to directly load the Initrd. So we will need a piece of code between bootloaders and a static Initrd to verify the signature first. Also, we may think about, it's good to have a generic one, but we also think about system extensions that could probably extend dynamically your static Initrd. And just providing one like that, also in your bootloader, it will not work. So we can think about the unified kernel image that will answer these questions. So what is it? The UKI, or Unified Kernel Image, it's an all-in-one binary that contains all stuff needed to boot. It will first have stub sections that will act like a bootloader, then the kernel with all these modules, the initramfs, and the kernel command line, and other stuff. It allows to centralize heavily build. The Initrd will be built by the vendors. So that's why what was needed to first build our static Initrd to after create our UKI. So everything also will be signed in the same time because it's just one big file. So if we provide that, the distributions become more robust and more secure. Also, so I think it's a UEFI binary files. If we go more in details, the UKI will have sections, and all components are defined into this section. So you have the .linux for the kernel, you also have the .command line or the .initrd. And UKI have a really great features. Here I have some discovery mechanism. The first one is a discoverable partition specifications. It aims to automatically find where will be your root file system. In that way, you will not be able, you are not needed to provide the UUID partition where your root file system is. But therefore, the consequences of that, for now you can only use UKI with just one root file system. But it's an automatic discovery, so no need to add this information into your kernel command line. Also, we have the other mechanism of discovery, it's a system extension. It will use some additional files to extend this own content by using first the systemd stub, so it's the stub section into the UKI, and it will use systemd sys extensions. Talking about extension images, it aims here, because by default, systemd6 extensions will extend your file system. But for the UKI purpose, it will extend the Initrd via an overlay file system. We have two kinds of extension. You will have the sysx for extend the user and OPT directory, and you will have a conf extension to extend your etc. Extensions are raw images that we can already created through OBS and assign them. And an idea of using extension is it could be useful to dynamically overwrite the Initrd by, for example, adding new modules to the UKI. We have another companion files called add-ons. add-ons are other UEFI binaries, and they aim to it's used to pass additional kernel command line parameter by updating this own CMD lines. So it's another UEFI binary. So this time will just contain a PE section command line, and then the stub part of your UKI will take this command section to add to the own kernel command line. So we can think about using them to add a command line parameter like a root flag option, for example. Then recently, the last new feature that we can say about UKI, it brings multi-profiles. It's useful to support multiple or different configurations that you probably want to use with the same UKI. It means that with just one UKI, you will be able to boot one covers a regular boot, or implemented the factory reset logic, or booting into the storage target mode. It introduces a new PE section into this file called the .profile. So that's an example of how the UKI could looks with profile. It comes from the documentation directly. So we can see that you will have your basic sections, and then for each profile you can add a new kernel command line. But keep in mind that these sections need to be into your UKI. Okay, and where are locating all these files, all these add-ons and extensions? Basically, for distribution build UKI, it should be installed into your kernel modules, and all companion files need to follow this path. You can have extension or add-ons dedicated for the specific UKI, or you have a global extension. It means that everything that will be into UKI extra.d will be applicable for all installed UKI. And for USP partition, so where your boot is, it follows the same logic. So you have your UKI in the UEFI directories and companions that follow him. So that was the theory. Now, the goal is to building a unified kernel image. So as for the static Initrd, we have multiple tools that we can use. The first one that I can list is Dracut. Dracut can create, of course, Initrd, but if you add UEFI argument, it will be able to directly transform your static Initrd into a UKI. But I have in mind to keep the build of static Initrd and UKI in two different positions. And it exists another tool that is really made to create UKI. It's called the UKFI commands. And UKFI, so it's written in Python. It's provided by systemd from the version 2.5.3 with many great features from the version 2.5.4. And it allows to generate a UKI from a pre-built Initrd and pre-built kernel. You can also sign your UKI by using directly this command, and this command will also can be used to create add-ons. But I was needed some different process, to manage my UKI, to install in my bootloader, to generate one, to generate an extensions. So let me present to you a tool that I have created. It's called the UKI tool. We can describe it like the UKI Swiss Army knife for packaging, because it would be useful to create UKI in packaging level. It is a tool that I've wrote in full shell script in a POSIX compliance, and it provides some commands. You will have UKI to create, basically to create a UKI using the UKFI tool behind the hood. You have the extension command to create a well-formatted extension for your UKI or for all needed UKI, also for add-ons. And most important, I have brings two commands, grep2 and sdboot. It will allow you to install and manage all entry around your UKI. For sdboot part, there is also the sdboot util command that you may know. The goal will be to move all work into the sdboot util in the future. But we will see that I have some limitations that I cannot do right now. So now I have, so this tool is accessible directly on my GitHub account on the Unified Kernel Image tools. And I have creating also sections to discuss about a UKI process. If you want to participate on giving an ID, because it's still an experimental way, you can go there to talk about UKI. And I'm using this slide to really thank Tobias that helped me a lot to discuss and helped me to progress on the UKI way. So thank you, Tobias, for that. So now that I have the correct tool, I will be able to build and publish my Unified Kernel Image. So as for the static Initrd, I have created RPMs using spec file. The RPMs packages will call UKI. It will follow the static Initrd versions and the kernel versions to know where it come from. Into the build sections, I call the UKI tool create command. And what we wanted to have, it's like the kernel package. When you install your kernel, it will be directly have a bootloader entry for that. So on the post-installation script, it will be the script that will be run after all your package install. It will be called the UKI tool to install your UKI in UEFI partitions and add a new bootloader entries. So sdboot or grub2. But keep in mind that for now, it's not by default. It offers a new way to boot your image. It will not become the default bootloader ways. But with that, installing this package, you will be able to choose to boot directly on the Unified Kernel Image. And yeah, on factory, so on Tumbleweed, that is what is published right now. So you will have UKI default and UKI vanilla. So as is named, based on the kernel default and kernel vanilla. Both take the static Initrd generic flavors to have the more generic ones. And you will also find my UKI tools that is also provided on Tumbleweed that you can use to build your own UKI if you want, or to manage easily the integrations in your bootloader entries. And when you install the UKI, there is a location where the UKI is installed, so it follows what I described just before. And it will give you the certificate, because this time, yes, this UKI is signed to have a full secure boot chance. But how is it signed? I'm using for that a good features in a OBS. It's called, I call it the need SSL set for build. So it's a magic command that you can add into your spec file. OBS will use the PE sign tools to sign the list of binary you have chosen into your build sections. And it will provide to you the certificate that has been used to sign the binary, so it allows you to enroll their certificate into your mock if you don't have yet. So that is how the UKI is signed. And yeah, more technically, I give you the example of the spec file. So you have the need SSL set for build to activate this feature. On the preparation step, I can get the certificate that is used. And in the installation sections, I provide into the BRPP sign files what it needs to be signed. So in that case, my UKI. So yeah, just with that, we have a possibility to have a full secure boot chance. Now we still have some experimental works and some ongoing works with the UKI. And the first one that come in mind is how it can work with snapshots. You may know already, but with openSUSE distributions, it uses btrfs file system that allows you to have a system recovery by using snapshots. Snapshots are created by the snapper tool, and for each snapshot, the snapshot will be created incrementally. And to boot on a snapshot, when you want to have the recovery, you will need to add into your kernel command line from which snapshot you want to boot. So for this example, it will boot on the snapshot number 42. But that is a problem with UKI. Because when we provide the UKI signed, I am not able to update dynamically the command line sections, otherwise it will just cancel my signatures. So the problem is I cannot determine how many snapshots it will have of the specific client user. So an idea would be to create an hard-coded snapshot names to know in advance what will be the name of the snapshots. So we can think about fix a number of symbolic links, and into the snapshot folder, you will have cyclically all my symbolic link, so called here UKI1, UKI2, UKI3, that will always link to the n last generated snapshots. Using that, whole command line become predictable, and I will be able to create all add-ons in advance. But yeah, it's not finished with that. I also have another problem. If you want to use add-ons with the UKI, because add-ons aims to provide and update your kernel command line, if you provide them into your ESP partitions, the UKI will try to load all add-ons. You have not the possibility to choose which add-ons to load. Where for building, booting on the snapshots, you will need to say, okay, I boot on the UKI, but only on these specific snapshots. So for that, we need to think of a new type of add-ons. So we have the first one is the global ones, and the UKI dedicated one. So it's what exists right now. And we can think on specific add-ons where using the bootloader entry type 1, you can choose which add-ons to load. So this example is come from only systemd boot. It's one way to create a bootloader entry. So it's an entry type 1, where you provide the configuration files where you will say what you need to boot. So you can replace all keyword by a kernel and Initrd to boot a regular kernel on Initrd, but you also have the UEFI keyword to boot a UKI. And then it's not exist yet, but we can think about adding a new line called the add-ons to tell systemd boot you will load the specific add-ons. And that's what it's actually doing, this pull request on GitHub in a systemd side. It implements this kind of add-ons. It will allow you to select which add-ons to load. So also, yeah, something important, you will need to create a snapper plugins that will automatically, for each new add-ons, new snapshot generating on your system, install a corresponding add-on file into your UEFI partitions, create the bootloader entry, and reorder the symbolic link to always link on your last generated snapshots. So all of what I have explained to you, I have creating an experimental packages on my personal OBS, where I provide the systemd package. So it's a systemd from openSUSE versions with the change of this pull request that I just mentioned to you. And you will find the UKI snapshot package that will install for you the UKI snapshots and all add-ons into the corresponding locations. And if you install that, you will be able to have one UKI install and multiple bootloader entries that will just load one add-on, where the goal is to boot one snapshot. That was the first experimental work. The second one is some questions we have with extensions. So I just explained you what is an extension, but how can it be used? So it's an idea from a discussion with Tobias, where the idea would be to create one extension per Dracut modules. I just say to you that we use a static Initrd built by the Dracut commands that use modules. The idea here will be, if you have a generic Initrd, you will be able to create after extensions that will include just one module. And all dependencies of this module could be managed directly by the packaging level. So all these modules could eventually be built by the vendor, be signed together, and could be installed on your machines. And the goal, yes, it's to implement this process in the UKI tool also to allow clients or customers to directly create this kind of extension quickly without thinking about how to create an extension, and install this module directly into your boot UEFI partitions with all dependencies. So also, it's an experimental package that will come soon called the UKI extension. It will be in the same projects that I showed you just before on my OBS projects. And okay, so right now, what is done today on Tumbleweed, you can already install an unsigned static Initrd with some dedicated ones, the UKI tool, and the signed UKI. There is a proof of concept to work with snapshots already implemented, And we have opened community discussions in our GitHub section to have all feedbacks on all discussions around that. What is actually ongoing, it's yes, integration with the snapshots and work with multi-versionings. Because what we want also is to have the possibility, of course, to be able to install multiple versions of UKI. It's a work that is in progress. And what it needs to do now is to work on the proof of concept with Dracut module extensions and an adaptation with a new grub2 bootloader specification BLS. That's what it needs to do. Okay, I hope that I give you all information needed for the UKI on openSUSE. And if there is any questions, we have 5 minutes left. So as I'm here, I am ready to answer if there are any questions. Maybe it was really clear.
Thanks for the talk. One question, how is the signature of this UKI checked? At which stage, or is it a CA, or how is the signature checked?
How the signature is checked during the boot? Yeah. It's already done by the regular signature. It means it will use the same check as is done for the kernel, by the way. The UKI will be signed in your OBS, and then the signature will be checked directly on the boot time as it's done actually for the kernel. And you will need, oh yes, of course, I didn't mention that, but it uses a secure boot. If you have the secure boot enables, then you will have all signatures that will be checked. Yeah. Good question. I didn't mention about secure boot. Thanks.
And another question, these extensions or add-ons, are they signed as well?
Exactly. Because extensions are raw image and add-ons are also UEFI image. So I have applied the same process as I have done for the UKI. So it will use the OBS features to sign them, and I will catch the certificate to be enrolled. But as now UKI and extension will aim to be on the factory side, the certificate will be the same as for the kernel, I guess. So, but yeah, add-ons and extension will be signed as same as for the UKI. So you will keep, even if you want to dynamically extend your UKI, you will still have all security around using secure boot also.
How is boot time affected?
It's a really, really good question. Because, yeah, when we increase the size of the Initrd, it's a static one, so we will provide more service inside them. So, of course, the boot time will be effective. I do not have specific time comparison for now, but if my virtual machine can boot without that in maybe 5 seconds, it will just double the size of the boot time. It's not really, in my opinion, it will not. It's not too long to boot. But of course, it will be more longer if you're just using a dedicated Initrd, yes. Okay, I think so. If there is no question, thank you. Oh, yes, maybe one.
So you mentioned that you no longer need to specify the root partition as boot parameter.
Mm-hmm.
So far, so good. But what if someone has multiple partitions that look like valid root partitions?
Yeah, it will. Even if you provide multiple boot partitions, from my test, it will test the first one that it will guess as a root partitions. So for now, yes, it's not made for other different boot partitions with just one UKI. It would be a really good project, by the way, to create another proof of concept, to have a way for the UKI to use a multipath process. But for now, yes, only one will be chosen automatically. Okay, perfect. Thank you very much, and have a good time.